So this is a complete review today at the beginning here of what we taught you on Friday. You're supposed to know how many terms this polynomial has. You're supposed to know what the lead term is, the lead coefficient, the y-intercept. The right end is doing what? It's either up or down. Left end is either up or down. And the last thing is what degree is this polynomial. All right, you're going to know some number of these. Hopefully you know all 7. If not, talk to that kid next to you and see what they have for all 7. So, here we go. Row 4. First person, Luke Wilford, you're going to answer a couple. How many terms does it have?
4.
It has 4 terms. 1, 2, 3, 4. 4 terms. What's the lead term?
-7 x third.
Very good. What's the lead coefficient?
-7.
You are correct. Now the y-intercept, we will move on to row 4. Hadley, that's you. What's the y-intercept on this one?
0.4.
Ooh, I love that you didn't just say 4. The y-intercept has x equal to 0, so 0, 4. Nice. The right end, Hadley, up or down?
Up.
Unfortunately not. This negative here tells you it's down on the right.
Right.
Yep, the right end. That tells you the right end. I know it's kind of counterintuitive because it's on the left side of the equation, but that tells you the right end is down. All right, Carlos, the left end. Is it the same or different? Because this is odd, the degree is odd, that tells you it's different. And if it's different, it must be up. All right. And Mark Smirsky, the degree on this thing?
3.
Degree is 3. Very good. Okay. Now, we have to look at problems that instead of are in an equation, we're going to give them to you as a graph. Everybody please copy down this. It's bouncing at -4. You guys all know that where those 2 lines intersect is 0, 0, so I don't have to even say what that is. And it's going through +4 at that spot. Now there's a graph. Thank you. Can you make the equation for it? Okay. I would be totally shocked if anybody got the complete right answer. But one little piece at a time, and with all of your brains working together, I bet you could do it. All of you together. I will try to coordinate that. Connor, can you tell me how all equations start?
1.
Very good. Next, we have to decide whether or not it's a negative number in front. Caleb Kimball, can you tell me whether it's a negative number in front? Don't just guess. Look at the way right side.
Okay.
See how it's going down?
Yes.
That's a hint.
Negative.
It is a negative. Next, we need not just one set of parentheses for this dot. We'll need another set of parentheses for this dot. And we'll need another set of parentheses for that dot. Bennett, can you take a stab at what one of those parentheses would be?
x plus 4.
X plus 4 inside the parentheses. You are correct, and that's for this one. But there's more. This is one of those straight A student questions that, you know, you get your chance to figure out the R4 here right now. It can't just be x plus 4 because it's doing something unusual. It's bouncing. It's kind of like a little parabola all by itself right there. It's bouncing off the x-axis. Anybody want to take a shot at that?
X plus 4 squared.
Yes. Very nice. Like, how did he know that? I did give the hint that it's kind of like a little parabola in the midst of this whole other function. And parabolas have a square down. And they have a curve like that. They're bouncing. Okay. Now, I don't expect you to get the rest of this equation completely right, but somebody can get a little bit more. Andrew?
X plus 0.
X plus 0. Ooh, how'd you know that, Jack? This looks like the x cubed function. It's like an x to the third graph. They kind of have that weird curvy thing where really what's happening is it's that at 0, it's an inflection point where it changes from slowing down to speeding up. It's changing the speed it's going. So that is called a triple root. And last but not least, this is actually the easiest part. I need to do this one. And the cool part is it's just normal. It's just like passing through it. And so what is it? X minus 4. There. That covers like 3 questions on your next test. There's single, double, and triple roots. This is called a single. This is called a double. It bounces. It's kind of like a little mini parabola. And this is a triple root. Remember, the roots are the same as the x-intercepts. And the triple looks like x to the third. Like a little mini x to the third in the middle of your graph. Okay. There's a lot more. But I want to practice this one more time. So I'm going to give you a new one. I do not need you to copy the picture. I just need you to write me the equation like this. Okay? So here's the picture. This one's going to bounce here. It's going to bounce there. It's going to go down from there. This spot's at -3. This spot's at 4. Can you write the equation for that? If you're stumped, you just try to get something. Like Jonah, how do they all start? Good. And next, even if you were stumped, you'd at least know that there's a parentheses, right? All right, see if you can finish this puppy. In a moment, I'm going to ask you to compare with the kid next to you, and maybe you'll have figured out something that they didn't. I'll pause for a second while you give this a try. So here we go. This one, you should have said that there's a -3 here, so it would be x plus 3. And then this one's an x minus 4 for the other one. And then I just did 3 things wrong. Smirsky, can you name one?
You need to put a negative.
Yes, it's going down on the right. I know a lot of you just forgot that negative right there. Okay, next. They're both bounces. Squared, squared. All right, next I got to teach you what's called a local maximum, relative max and relative min. Would you agree that this is a maximum spot? It's kind of like a high spot. And there's another one over here. And that both of those are the highest that the function ever went. Like that's the highest it ever went. That's called the maximum. This green spot is relatively a low spot. A minimum. It's called a relative minimum. Why don't we just call it the minimum? Because it's not the lowest that the function ever went. It's just relative to the things near it, it's a low spot. It'd be kind of like, in this room, there's probably some kid who is the strongest of all of you when it comes to arm wrestling. We could do an arm wrestling tournament, figure out who's the strongest in the room, okay? And I think I could beat you, even though I'm old, because I have old man strength. All right, anyway, so let's say that you are the strongest in the room. Well, that means you're locally the strongest, or relatively you are the strongest. Does that mean you're the strongest of all kids in the whole high school? No. There's probably some kids sitting in another room who would beat everybody else. Okay, so my point, this is not the lowest of them all, but it's relatively low, so it's a relative minimum. These are the highest that this function ever went, so that is called the maximum. They're tied to be the maximum. Now let me give you one that's a little different. Green spot, blue spot, white spot. Which one is the maximum? The white one. The green one is not a maximum, but it kind of is a maximum. So what do you call it? Relative maximum. Good. The blue spot, what's the name for that one? Relative minimum. Why isn't it just called the minimum? Because there's spots that are lower than it, like over here. In fact, it goes down forever. So there is no minimum. There's no lowest spot. It just keeps going down forever. But there is a relative minimum right there. And this is a relative maximum, and this is also a relative maximum because it's like the highest locally, but it's also the maximum of them all. So it's not just locally a relative maximum, it's also the absolute maximum. All right, then if I were you, I would copy this next part down. So copy this graph, just make a quick little sketch of it, because I'm about to teach you something that I think is incredibly easy, and yet gets marked wrong on the tests a lot. And it is called increasing and decreasing intervals. Once you get this, it should be a happy place, should be an easy question on the test, but I know from experience that a ton of kids find this confusing. All right, so copy this picture down, and then we're gonna say that we're gonna name each point. We're gonna say, this point is exactly here. Okay, so the blue point, that's gonna be the point 0, 2. That top point there, that's gonna be the point 5, 6. The green point is going to be the point -3, 3. Now, if you were to ride on this function and you were like in a little cart, kind of like you're going over I don't know, you're at Valley Fair and you're on a roller coaster, okay? Do you get, as you read from left to right, there would be some times when you'd be going up and sometimes when you'd be going down. Okay, when you're going up, that's called increasing. When you're going down, that's called decreasing. So if I was asking for the intervals where this graph was increasing or decreasing, I'm going to start with just one and talk about this one. It's probably the easiest one. That little white section of the graph there, would you agree as you read from left to right, it is increasing in there? So then you'd say it's inc between what and what. Now, I get this is the moment where the confusion usually happens. Everybody gets that that's increasing. That's easy. But they confuse which numbers to use. I'll tell you this over and over, but let's see if you remember it. Only use X values. It's so tempting to pick the Y values because it's like, how high did it go? That's not the question. The question is, when was it increasing? It was increasing between 0 and 5. The question isn't, how high did it increase to? That's not the question. The question is, when, which is like time, which is like the x-axis, was it increasing? It was increasing between 0 and 5. Now, if you understood that, you should be able, I know this is not easy, to tell me that it's decreasing over here between what and what? Now notice, it keeps going down forever. X values. Use X values. Andrew, take a shot. You used a Y value. But you started with 6 comma. Did I have to use X values? So you gotta start with 5 comma. See, we only use X values. Between 5 and, did you say infinity? You were correct. Now, some kids are like, but it's going down to negative infinity. That's a Y value. See this X value here? This thing continues on forever to infinity over there. We're talking about X values. So it was decreasing between 5 and infinity. Yes?
Should the 5 be in brackets?
Good question. No, for intervals, we only use parentheses the whole time. We don't do the bracket parenthesis thing. It actually would get really complicated because is it actually increasing at 5? Or is it decreasing at 5? Or is it not doing anything at 5? And so it's hard to tell whether you should use a bracket or parentheses. So we keep it simple. Just use parentheses for every one of your increasing and decreasing intervals. All right. Now, there's only one other decreasing interval on the whole picture. Can you please tell me where's the other places it's decreasing? Remember, it's as you read from left to right. Hopefully you at least knew I was talking about this red zone right here. I just made it red. It was decreasing in there, and if you just know that it's the X values, it'd be from -3 to 0. It's the only numbers you can pick, because they're the X values. All right? And I totally get why this zone right here, this green zone, confuses people because they think it's decreasing there. It is not. It is increasing there because you read from left to right. So would you please write that interval? If today feels like a lot, it is. It's because it's actually 2 lessons. Why would you do 2 lessons at once? Because do you remember that I gave us an extra day to study for the cumulative? That got us behind a day. So then you gotta pay for it later, which is today. We would have had 2 easy days, but now we gotta scrunch 2 easy days into 1 day. All right. So that was increasing, and I used the X values only. And, well, I know that I got to use a -3, but that's on the right side of it. And if I'm looking for an X value, it would be what is over here. What's way over to the left on the X axis, and that would be -infinity. Who had -infinity? Nice. -infinity to -3. Okay. Now, here's your final test on this. This is like the whole day is all we would have had to do that day is increasing and decreasing intervals and relative maximums and relative minimums compared to absolute max, which is like highest of them all, and absolute minimums. So here's a question that will really make sure you get this. If I say that this spot right here is the highest it is in that area, and it's at -1, 3, and this is an important spot. I won't give its name, but it's at 3, 1. you should be able to tell me all the increasing and decreasing intervals and where is the local, no, I shouldn't say that, relative min and the relative max and the absolute min and the absolute max. Now, do you have to be an expert at this? No, you don't have a test for like 2 weeks. You walk out of here today, hopefully you've got most of it down. We'll get the rest of it later. Dice of Destiny. I really likes row 4 today. Jonah French, what is the increasing interval?
Negative infinity.
That's a good start. That means way to the left because these are x values. Until when does it stop increasing?
-1.
Good. Negative infinity to -1. Is there another increasing interval? Yes, there is. Jack Breen, what's the other one?
3 to infinity.
3 to infinity. I'm just putting INF to remind you that you can use INF or you can use the infinity symbol. Decreasing interval. There's only one of them. Caitlin.
Decreasing interval is -1 to 3.
-1 to 3. Very good. Using x values only. The relatively minimum spot. Relative minimum. Tomas.
1. 3, 1.
There you go. Got to give the whole point. Yep. The relative minimum is at 3, 1. The relative maximum, Isaac.
-1, 3.
Excellent. And Luke, the absolute min and the absolute max.
Would that be negative infinity, negative infinity?
Nope. Absolute min. Carlos. I think it's because you know and you don't know how to say it. Think about it a little harder. The absolute minimum means like the lowest of the spots. It doesn't have one. It doesn't have an absolute maximum. But you can't say I don't know on the test. You have to say there isn't one. There isn't a lowest spot and there isn't a highest spot. All right. Have you got good notes on that? Because if you wrote that down, you have like a 70% chance you're going to remember it now. All right. So, what does a typical homework question look like for today? Here's a typical question. They give you this, and they say, do you know what that would look like? It's got a curve. It'll end up with a high spot, which is called absolute maximum. So here's how I would do them. I'd go, okay, is it doing anything weird like bouncing or triple rooting, like where it's kind of like a snaky, curvy thing? Nope, it's just normal dots. So I got one at -3 and I got one, nope, wrong. One at -4, one at +3. And now, since there's a negative here, it's going down on the right. That's all there is to it. Because that one's just a quadratic. You just had a test on those. You should have been able to do that on the last test. This should be nothing new. What would have made it new is if I would have like squared one of them. And then you'd have to know it would have bounced off of that spot. Let's see if you can handle that. Y equals x minus 1 squared x plus 5. Okay, well, it's got to touch 1. I'm smart enough to know that that doesn't mean negative 1, it means positive 1. And the other one would be negative 5. Did you even look to see if there was a negative in front? Good. If you looked and you realized, oh, it's positive, then you'd know it would be going up on the end. How about the other end? Is this degree 2 or degree 3? Be careful. Okay, now this will separate the A's from the B's on the next test. This next little step I'm about to do. Because if you do this extra step, you're smart enough to know how to do it, and it'll be double checking your answers. And somebody just thought that this was degree 2, and that would be a fatal flaw. Because then you'd think that both ends should be going the same direction. It's not degree 2, it's degree 3. So here's what you do. You always figure out the beginning term. Remember me saying that there was this flyover country where we didn't care what happened in the middle? And then you had the y-intercept at the end. All that really matters is how does it begin and how does it end. And the way it begins, you get that from this and this and this, and that makes x to the third. My lead term tells me, since it's positive, there's no negatives on it, right? So then if it's positive, it must be going up on the right here. My y-intercept is where x equals 0, so I put a 0 here and a 0 here, and I go negative 1 squared, which is 1, times 5 is 5. It's 5. If you take the time to do that, you'll be in the top 25% of the class, because it takes extra time, but then you don't screw up things like the y-intercept. The y-intercept must be at 5. It must be like up there. If your y-intercept isn't up there, you're doing something wrong. See? And that means, how in the heck am I going to get up there? Because I must bounce off of this thing. Bounce comes from this. That makes it bounce. And then I think it's going down on the left. How could I check? Because if it's got an odd degree, the ends have to be different, and my ends are different. My y-intercept is positive, and that's just what I have, so I'm doing it right. I double-checked it. That's how you can make sure you're doing these right, is you figure out the lead term and the y-intercept. All right. One more. Take a second to figure out the lead term and the y-intercept. All we care is how does it begin? Don't care about the middle. How does it end? And then you'll be able to sketch it. If you're like, I don't know how to do just an x, think of it as an x plus 0. And you're asking yourself, how could I make that part 0? It goes through 0. And it goes through negative 2. Hint, it bounces somewhere. Quinn Koenig, can you tell me what would have to be the lead term? Hint, it starts with a negative. Can you go through and multiply them quick? x to the third. Because this x squared would go with this x, and when you multiply them all together, you get x to the third. And the negative's in front, so it's negative x to the third. All right, Allison Carr. The y-intercept is where what? Said this saying so many times. The y-intercept is where what? Good. So put in x equals 0 in your head and then figure out what would be here. Nope. Because you times by 0 right here. What's negative 4 times 0? 0. I know, it's weird. The y-intercept's 0? Yes. Because when you put in x equals 0, you'll have a 0 right here, which means 0 times anything makes it all 0. That's because it's going through the y-intercept of 0. You could have known that just by knowing there's a dot right there. All right, and last, I gotta go, do I end going down or up? Jonah French, does this equation tell you you're gonna end going down or up?
Down.
Because of why?
Because there's a negative.
Yes, the negative out front here tells you it's going down at the end. Is it bouncing off the 0? Jonah?
No.
No. Is it bouncing off of the negative 2? Yes, because of this squared here. Boing, and it goes up. Now, does it match up with what you already know? You know that if it's negative, it should be going down on the right. It is. You know that if it's odd degrees, that means the ends are different. Are my ends actually different? Are the ends actually going different directions? Yeah, so that part checks out. And is it going through a y-intercept of 0? Yes, that's how you check it. And see, this part right here is not required. But that's what'll make sure that you don't screw it up, and that's what separates the A's from the B's on the next test. Take the time to find the lead term and the y-intercept, and then you won't screw these up near as much as everybody else will. All right, now this is the part where I need to pull in a worksheet. I need to pause for a second to pull that in. Okay, I have put that in. So now I can... There's your homework. Looks like that. I will start it with you, and then I'll tell you which part you have to do and which part you can skip. Okay, consider the graph below. A, identify the intervals on which the function is increasing. Okay, so the first thing you do is write INC, parentheses, and a comma. That's how you do every single interval you'll ever do. Parentheses with a comma. Do you see the spot where it's increasing? Am I going to use X's or Y's for that? X's. Luke Wilford, what are the two X's involved?
1 and 3.
1 to 3. I get totally why a kid last hour said that was at 0. He was using the Y value. But see, between these two dots, it's increasing, which is between 1 and 3. Perfect. Is it ever increasing anywhere else? Nope. Is it decreasing somewhere? Yes, it is, but they didn't ask you that. Okay, part B. Give the coordinate of the relative and absolute minimum. Is there an absolute minimum? No, it doesn't stop going down. It goes down forever. How about, is there a relatively minimum spot? Yes, and it is at 1 comma negative 4. I'm going to put RM for relative minimum. Is there a relative maximum? Alice, what's the relative maximum?
3 0.
Yes. Part C. State each root and its type. Is it a single or a double? All right, the two red spots I had on there, I'm taking them out. Now I'm going to put a couple green spots on here. Those are the roots. Roots are the x-intercepts, the zeros. They're all the same. All mean the same thing. So the roots are those two green spots. And what are they? Well, they would be at 0, 0. And Now I should name what type that is. Is that a single, a double, or a triple? That's a single. What is the single, double, triple thing? That means, is it just passing through it? Is it bouncing off of it? Or is it making that weird x to the third shape that's kind of like a cubed? This is a single. The next one is at 3, 0, and it's a double. The leading coefficient is negative because it's going down on the right. All you know is it's negative. Now from there, I would check you probably want to know which ones you could do and skip. You should do 1 and 2, but you may skip 3. The only one you can skip is problem 3. It does have a bunch of parts that will save you a bunch of time. Skip number 3. All right, that's all I got for you for today.